We move on from parabolas to talk about ellipses. Now, ellipse is basically a slanted cross-section of a cone, as you can see in this picture over to the left. And the definition, or the accurate definition for an ellipse, is the set of all points whose sum of distances from 2 points is a constant. So you can see here that F1 and F2, which are focus points, foci, plural, are somewhere in the middle of the ellipse. And if I were to take a string, if you will, and lock it onto these 2 points and then pull this pencil around the ellipse, or pull this pencil tight, then you would form an ellipse. And here's an illustration of that. You'll notice that at 2 fixed points, the string's being pulled around. The lengths of the blue and the red line are changing, but the total length is constant. So that illustrates definition of an ellipse. Now, within an ellipse, like I said, we have these 2 foci points, F1 and F2. We also, as usual, have a center. That center is always given as HK. And then we have a couple of axes. The distance from the center out to the end point here, this is called a vertex, V1. And this is a vertex as well. And that distance from the center out to the vertex is A. Now, we're going to call this up here a covertex. Some books call it a vertex. I'm not a big fan. And this is also a covertex. And the distance from the center out to that covertex is B. The vertex is always the longest of the two. And we call the axis that's made up of the vertex the major axis. And that has a length of 2a. We call this other axis here the minor axis. And that has a length of 2b. The length from the center to a focus point is c. If we want to write an equation for the ellipse, we can do so in the following manner. For an ellipse with a horizontal major axis, in other words, kind of laying long, we have x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. Or if I have a vertical major axis, so a tall standing ellipse, then I have x minus h squared over b squared plus y minus k squared over a squared equals 1. And remember, in both of these cases, a is the longest term. So you can distinguish what type of ellipse you have by finding the biggest denominator. And wherever that biggest denominator is under, it's under the x, it's horizontal. And if that biggest denominator is under the y, it's vertical. Now there's a relationship between A, B, and C. If I were to take the B length, connect it with the C length, the distance from the 2 points would actually be A. In a right triangle. So I have A squared equals B squared plus C squared as a relationship between A, B, and C for all ellipses. So use this information to do some problems. We want to sketch an ellipse given by the following equation. Well, what I know initially is I have a center at -2 and 7. My A term is equal to 5 because that's the biggest. B term is equal to 4. So I should be able to sketch an ellipse just from this. Here's -2 and 7 up. and then I go over 5, and I do that vertically. So there's 7, and then I go up to 12, put a dot up here. I go down 5, which is a 2, put a dot here, and then we move to B, which is 2 over. So I move to 0, put a dot here, move to 4, put a dot here, and then connect the dots in an oblong shape. And that's a rough sketch of an ellipse. Once again, just kind of a sketch, not super accurate. All right. Let's move forward. We want to find the center, the foci, and the vertices of the ellipse. And remember, the vertices are only going to be points at the end of the major axis in our case. So let's go ahead and do that. We know just by looking at the picture, we have a larger denominator under the x, so I'm going to get an ellipse that looks like this, horizontal major. I know I have the center at -2, -5. My A term is equal to 6. My B term is equal to 4. And I know I have a relationship between A, B, and C of A squared, which is 36, is equal to B squared, 16, plus C squared, which is unknown. I can solve that. Bring the 16 over, I get 20. It's equal to C squared. And C is equal to 2 root 5. And with all this information, I should be able to find all the points I need. Once again, we've already got the center. It's right here. I like to draw a picture just to reinforce what this thing's going to look like. So if I go from -2 to -5, there's my center. I know it's a horizontal major axis, 6 in either direction. So there's 2, 3, 4, 5, and 6. Puts me out at 4. So, and 2, 3, 4, 1, 2, 3, 4, 5, 6. Puts me over here. So in order to draw my vertices, I basically say, well, I'm going to start at the center point, which is -2, and travel to the right and left direction, total of 6, and then I'm down -5. So that gets me a total of 4 and -5, and -8 and -5. And those are my two vertices. The foci, fairly similar, except I can't really count 2 root 5, but I'm going to move on the same axis as the major axis. Somewhere in between those 2 points, let's call that 2 root 5 and 2 root 5 here. So for the foci, I'm going to say start at -2 and move left and right, 2 root 5, and go down 5, and that gives you the foci. Now I want to write the equation of an ellipse, having following vertices and a minor axis length of 6. So let's take and draw a picture. Find that's the best way to go about things. 0, 7, and -7 land somewhere here. And these are vertices, so this is my major axis. Therefore, that means the length between the two is 2a. So if I split that distance, I'm at 0, so I have a center at 0, 0. I have an A distance of 7. And my 2B distance, since my minor axis length is 6, I have a B length of 3. Therefore, I should be able to write this equation. If my center is at 0, 0, I have x minus h, or x minus 0 squared, plus y minus k, that's y minus 0 squared, Now, I know my vertices are 7 and -7. That means I have a vertical major axis. That means my greatest value needs, or my greatest denominator needs to be under the y term. Therefore, a squared is 49 and b squared is 9. And that gets me my equation. Let's do similar with the following example. I now have vertices at 1, 5 and 1, 13. So again, I will draw a sketch. Call this 1, call this 5, this 13. These are my vertices. And right off the bat, I can tell you I have a distance of 8 between the vertices. Therefore, halfway between there, or 4, is going to be where my center lies. So that's going to be a 9. Therefore, since these are vertices, they're vertical, and I have a center now at 1, 9. I can begin to write my equation. Let's do that. I have x minus 1 quantity squared plus y minus 9 quantity squared equals 1. My biggest denominator is going to be under my y term, and that's going to be the length to the vertices squared, so this would be 16 here. All I need to do is find my b value, but I don't really have that yet. I have a focal length, so from the center out is going to be my focal length, and I know I have a focus value at 1, 7 and 1, 11, which means my c value is equal to 2. Once again, I know that a squared equals b squared plus c squared. Therefore, a squared is 16. I'm looking for my b value. My c value is 2, so c squared must equal 4. 12 is equal to b squared. 2 root 3 is then equal to my b value. All I really needed though was my b squared value, which we found out was 12. And therefore I've got the equation of this ellipse. So in this case, you've got a situation where it appears to be a general formula, and I need to complete the square in order to get my perfect squares in the problem. Now, in order to complete the square, remember we need coefficients of 1 in front of the x and the y squared term, so I'm going to have to do a little factoring to get this problem done. I'm going to first start by bringing the 16 to the other side, factoring out 16 for the x squared term, leaving me with x squared minus 2x. And then likewise pull out a 25 for the y terms, so that's y squared plus 2y. Complete the square on the negative 2, and I get half of 2 squared is equal to 1, and once again half of 2 squared is equal to 1 here. Now you'll have to notice though, I have to keep my side balanced. It appears that we've added 1 to both sides, however we really added more than that. Because we're multiplying, I've added a multiple of 16 times 1 and 25 times 1 to both sides. So I'm going to add 16 and 25 to both sides, thus giving me 16 times x minus 1 quantity squared plus 25 times y plus 1 squared is equal to 25. So from here we're going to set aside equal to 1. I divide and I get 16 times x minus 1 squared over 25 plus 25 y plus 1 squared over 25 is equal to 1. Clean this up, put it in the appropriate form. X minus 1 quantity squared over 25/16 plus y plus 1 quantity squared over 1 is equal to 1. Now we've got to figure out which is the bigger number between 25 over 16 and 1. Clearly that's 25 over 16. Therefore this is my a term, this is my b term, or I should say a squared and b squared term. And I'm going to need that to find my c term in order to find my focus. So I know that a squared, once again, is equal to b squared plus c squared. Got my a squared term, 25 over 16. I got my b squared term of 1, which I'm going to call 16 over 16. And that's going to leave me with my c squared term, which I need to find in order to get the focus. So I subtract 16 from both sides. To get me c squared. Turns out c squared is equal to 9/16. So c is equal to plus or minus 3/4. To find my foci, I'm going to add that c distance to my center. I have a center of 1, -1. So for the foci, I take, and since this is a horizontal ellipse, I start at 1, move left and right 3/4, and go down 1, and there are my foci. In our last example, we've got an application problem that we're going to use. Talks about a truck going under an elliptical tunnel, and we know that the height of that tunnel is 10 feet and the width is 40 feet, and your truck is 10 feet wide and 9 feet high. You want to know if it's going to fit under the archway. So what I like to do on these problems is I like to center the truck in the middle of the tunnel and call the middle of the tunnel on the road basically your center point. So I know that if it's 40 wide, I have 20 on either side, 10 high, 10 from the road up, and then I know my truck is 5 by 5, and I'm trying to see if a 9-foot height truck will fit under that archway. So we've got to see how much room we have if I move 5 out, and how high will I be here. So let's write an equation for my ellipse. I know I have a center at 0, 0, so I have x squared over 20 squared because it's a horizontal major axis, plus y squared over 10 squared is equal to 1. This gets me x squared over 400 plus y squared over 100 is equal to 1. I know that in this case, I'm trying to find my y value at 5 out for my tunnel. So I'm going to move 5 on my horizontal direction, which gets me an x value of 5 over 400 plus y squared over 100 is equal to 1. Y squared over 100 is going to equal 375 over 400. That gives me a y value after solving of 9.6. So what this says is it says if I move 5 out, I'm a total of 9.6 feet up. My truck's only 9 feet, so this will fit. got a 6-inch clearance. That's basically all we've got today. Do my math lab, write your summary, and we'll talk a little more tomorrow.